Okay, continuing on with probability. The two rules in this section are called the addition and multiplication rule. And you'll see a little bit more of the conditional events in this section as well. So in order for us to apply the additional multiplication rule, we must have a compound event. And the previous video, that was a compound event, the probability you'd have a child and then another child. So basically combining two or more simple events. The simple event was having a child. You're going to see some more examples of that. So the addition rule helps you find the probability that either A or B happens. And to find the probability of either one or another thing happening in a compound event, it's the probability of A and the probability of B, it would also count if both occur one after the next. So the word or is when you would be using the addition property. So you basically are going to find one probability and add it to another probability, but making sure that if there's a sample space of only 8 things, that each probability only gets counted once in the final probability. So we are adding, and then we're still dividing by the total number of outcomes. The multiplication rule is whenever they ask you what's the probability that a specific event happens, and then instead of the word or, and the probability that something else happens after that. Again, this is where we're going to start talking about this conditional probability. You do not need to pay attention to this set notation. You just need to calculate probabilities, but that was the formal rule. Okay, so let's start it off kind of fun here. Imagine you're having dinner at a restaurant and there's 5 different kinds of pasta and 4 different flavors. This is just built for a probability question. Let's say you randomly select your pasta and the flavor of sauce. What's the probability they'll end up with bow ties or cheese? And that would be us using the addition rule. And then what's the probability that you'll end up with bow tie and cheese? So first what I want to do is draw a table of organize my probabilities, right? In the other video, I showed a tree diagram, and in this one, I'm going to use a chart. So let's put the kinds of pasta on one side of my chart, kinds of pasta, and spaghetti, bow tie, fettuccine, ravioli, macaroni. Those are my possibilities. And then the sauces I'll put on this side and make just like a little chart out of it. So we can have tomato sauce, we can have cheese sauce, we can have meat sauce, and we can have olive oil. So if I created this chart, it would show the combinations of all of these things. It's going to take me a little while to complete this chart, but hopefully you know where I'm going with this. So this would be spaghetti tomato, spaghetti cheese, spaghetti meat, spaghetti olive oil. Right? Bow tie tomato, bow tie cheese, bow tie meat, bow tie olive oil. You're kind of remembering that last video. It was like girl with the girl, girl with the boy, girl with the boy. You know? Okay, so F is F, fettuccine, fettuccine tomato, fettuccine cheese, fettuccine meat, fettuccine olive. We've got ravioli tomato, ravioli cheese. You getting hungry? Ravioli meat? No, I'm gaining weight just listing these out, right? And then macaroni tomato, macaroni cheese, macaroni meat, and macaroni olive oil. Okay, kind of forgot what we were doing there, but this is our sample space, right? And again, from the last video, sure, I could put them in the chart and I could count 1, 2, 3, 4, 5. But again, this kind of reminds me of elementary school multiplication, right? That it's a 5x4 grid. And so there's 20 different possibilities. And so in a table like this, we're not really applying that many rules. This is kind of like basic probability from the previous video. And so what's the probability they would get have bow ties? Bow ties would be anything in this row. What's the probability that they would have cheese? Cheese would be anything in this row. And so this idea that you're not going to use the same one twice is you're not going to double count this one, right? So that would be 1, 2, 3, 4, 1, 2, 3, 4, 5, but I'm not going to count this. So that's going to only be 1, 2, 3, 4, 5, 6, 7, 8 out of 20. You can reduce that by dividing by 4. But a lot of times I like divide by 2, like 8 divided by 2 is 4. Whenever I have even numbers in a fraction, I like to just cut the numbers in half until I get an odd. You can also change this into a probability. Do not change it into a percentage based off of the recommendation of the publisher. Okay. So that is do you want bow ties or cheese? Sometimes it's kind of funny. People are like, well, I just want bow ties. But this question, when it deals with probability, it's not a choice. Like, do you want bow ties or cheese? You would say yes, right? Both of them qualify as satisfying the probability that you're looking for. Bow ties and cheese would only be this single one that I selected. The one that was double shaded is actually the answer to this probability question, and that would be 0.05. Right, math teacher, I will double check. And so the probability that you'll end up with both, that's just 0.05. So that is 2 different questions related to a sample space of 20. In one case, I'm using what's referred to as the addition property, and in the other case, I am using the multiplication property. So here is the formal addition rule. The probability of A occurring plus the probability of B occurring, but then you subtract the probability of both events occurring. And I did the informal, but now let me show you what the formal is. So there's 5 kinds of pasta and there's 4 kinds of sauce. So the probability that I would select the bow ties, there was a 4 out of a 20 chance that I would have selected the bow ties. And then the probability that I would have selected the cheese sauce, so the cheese sauce was the second event, that was a 5 out of a 20 chance, right? And so when you add fractions, you just add the numerators. But that would be if I double counted the bow tie and the cheese. So then I have to subtract that one that they both had in common. So this is minusing or subtracting. Sorry, I don't know if minusing is a word. And that's this part of the formal probability rule. And so you end up with that 8 out of 20 that we did before. And so that's the formal rule if they pull away, if you don't have the chart and you didn't make the chart. So the other probability that I came up with was what's the probability you'll end up with bow ties and cheese? And that's what they call the multiplication rule. So it's the probability of one event happening times the probability of another. And so I could have just multiplied, and I'll show that in another slide. So let's think of another one where I don't draw the sample space, and instead I just use the multiplication rule. What's the probability that, you're just hanging out, you flip a coin, you roll a die. What's the probability that you flip heads and you roll a 5? So again, I could make a chart where it's heads or tails. I can make a chart where it goes 1, 2, 3, 4, 5, 6, right? That's the dice. And then hopefully you can figure that the sample space is going to be 2 by 6, right? So there's 12 total possibilities. But what the multiplication rule says is you can just think of the probability that you're going to flip heads when you roll a dice. I mean, flip a coin. I'm sorry, that's 1 out of 2, and then that you roll a 5, and that would be 1 out of 6. And that's setting up multiplication instead of addition. And that's whenever I'm trying to calculate what the probability of one event happening is, and then a second event happening. So this is like total out of all the possible things that could happen on the coin, total of all the possible things that could happen on the dice. And then if you multiply that, you don't add across the top. 1 times 1 is 1, 2 times 6 is 12. That will help you answer questions when they're asking you what's the probability of this and this happening. And if you can imagine this chart, it would only be 1 out of the 12 things that would happen. They didn't ask what's the probability that you flip a head or roll a 5. They said flip heads and roll a 5. And so it would have been just this single box right here. So that is the addition and multiplication rule. Multiplication, the word suggests multiplication. The word and in the math world is related to multiplication. And then the addition, the word or doesn't really suggest it, but when you hear or, it's like this one or that one. And so both possibilities can be combined. So that is your multiplication and addition rule. And that is just the beginning of this section. Please continue on and watch the next.